So now that we're recording, what I was saying before is for the practice problems I did 2 and 3 and 4 because 2 was a big unit of forces. Like I just looked back at it and it was so many topics related to forces. That's why it took so long, right? But once we have a good grasp of forces, now we understand how we can model motion and objects in 2 dimensions. And that's really important when we start to get into talking about projectile motion, right? So these next 2 units, to be honest with you, are probably gonna go quick because you have the foundation of understanding motion. Now we just got to put it in 2 dimensions. So the vector part we're going to go through between today and Wednesday, is going to give you the basics of how objects move in projectiles, but like also understanding like the individual components of vectors, so like their X and Y components, because we're talking 2 dimensions. And then what I want to touch on next week is how those vector components are applied to forces, right? So with that, what we're going to do is try and really, and I'm saying this because if it's possible, I want to try and get these next 2 units done within the next 4 to 5 classes. I believe we can get this done. And that's why I said 4 to 5, because if we can get all this done within the next 4 to 5 classes and even take that practice exam again on Monday, I think that's the 31st in class, whatever that Monday is on the 3rd, still of March, that'll put us at a good pace to where all of April we could really start playing around with sections 5, 6, and 7 and see how that goes. So that's the pace that I'm kind of moving. So I might move a little fast. Like I said, today might be a longer day. I said around 8:30. Well, let's see how this works. And then today will be a little bit of math. So if it does get confusing, don't feel free to stop me, because today will be some math in it. But I need you guys to have a good grasp of this because we have to apply this towards forces, right? So let's try and work through this today. I got majority of the slides for 3 done. I still got some stuff to add, so that's why you haven't seen it on Blackboard. But let's just go through today and work through it and see how far we get. And let's plan to have this unit done by next class. So let's see how we work today. Let's go from there real quick. And I know I'm talking, so if you have any questions, just come off mute. All right, can everyone see my slides?
Yeah.
All right, bad. Thank you. All right, so now, like I said, right? So let me go back. This unit is going to be vectors and projectiles, right? So understanding vectors helps us to get to understand how projectiles, right? When I say projectiles, I mean something flying in the air. And when we look at projectile motion, the common theme is having that parabola. So like when we talked about like the Michael Jordan problem, about how when he's jumping in the air, he has like the half parabola. Imagine all type of projectiles having that parabola shape, which means they could be described by the quadratic equation. And that, what we have talked about, comes and helps us understand the displacement equation that we have when we have time being squared and over time and moving the gravity acceleration, like that last kinematic equation, or third one I talked about. That really comes from understanding that projectiles move in parabolas, right? So that's where our end goal comes to really being at this question, to be able to say, how can we answer this one? That a soccer ball is kicked horizontally at 15.8 meters per second off the top of a field house and lands 33.9 meters from the base of a field house. Determine the height of the field house. This is a kinematic equation like type problem, right? Actually, the projectile too, but like using what we learned in the first unit, we should be able to do this. But this is going to require us to understand vectors and vectors components, right? And it's the typical prison problems that I want us to understand, right? It just has some numbers and a couple of words to describe what's going on. I need you to be able to visualize what's going on. I need you to be able to maybe draw a diagram, but then feel confident in the physics equations to where you're able to like put it all together. That's where we have to get to. So that's the end goal of this unit. So within that, right, we have a couple of topics, right? And I want you to see why I'm pushing so fast to get this done. The topics are not as dense as we had in kinematics, one-dimensional kinematics, and forces. It's just 6 topics, right? And I even dragged out the vector addition topic that you'll see, just because it's some math stuff related in there that I want you guys to be touched on, right? So you got vector representation, just how you represent a vector between its magnitude and direction, the addition of vectors, right? So how we do vector addition, like how we add them from end to end, you'll see that. Then once you have that, looking at the individual components of a vector, and then how you get to creating a resultant from that with vector resolution. And then now that we have our individual components, how do we add them together to then create a new resultant, right? Then that's the last part, getting the vector addition by components. Then once we understand all that stuff, which is math, right, we can relate it to some physics type problems, which is like understanding relative velocity and like riverboat problems. So those are good to like get us to bring in the vector stuff and apply it to real world problems. And then that'll set us up good to understand the real thing, which is projectile motion. And then once we have all of this, you have enough to be able to not only just understand these problems, but like really start getting into the lab stuff that I have set up. So that's where we're going with this, right? So now just to bring us back from where we started in unit 1, right? Here's a review, right? We have our 2 different quantities, right? Before I release it, does anybody remember what a scalar is? I could also see the chat too.
Yeah, like distance,
Go ahead.
speed.
Speed is a scalar, yes. Distance is a scalar. Let me see if somebody was saying anything in the chat. All right. What about vectors?
Acceleration,
Good. Anything else?
displacement,
Okay.
Something that has direction as well as magnitude.
Good. So something that has direction along with magnitude. So if that's a vector, what is a scalar?
Just magnitude.
There we go. That's what I was looking for. So a scalar is a quantity fully described by just magnitude alone, while a vector is a quantity that is described by both magnitude and direction. So that's just review what we have, right? Now I heard a couple of them, right? So now when we start getting into actual quantities, right? Distance. Distance is a what?
scalar,
Distance is a scalar. So if this is a scalar, then a vector would be what? Do you remember?
displacement,
Displacement. Good. Distance, the overall ground covered. Displacement, the overall change of position from object start to finish. Speed is a what?
scalar,
Scalar, the quantity that describes how fast or slow an object is. So then velocity is a what?
vector, yeah.
Vector, right? And that's the rate of change that an object's position changes. Then we have our last one, acceleration. What is acceleration?
The speed, the distance and change over time,
Almost. The rate at which an object's what changes?
changes over time.
But what, the displacement or the
The displacement.
not the displacement? Look at the definition.
I don't have it in front of me. I'm just trying to remember it by heart.
Oh, somebody come off mute, they can see it. Acceleration is equal to the change in what over time?
Oh, velocity, the rate
Velocity.
at which an object's velocity changes.
Acceleration is equal to, yes, an object's change in velocity over time. And velocity is a what?
A vector.
So therefore, acceleration should be also a
It's a vector.
good. So this chart look familiar?
Mm-hmm.
So we have that all together, right? We have our different quantities of vectors and scalars, right? Then that sets us up to now let's dive deep into understanding. Hold on, I think I let somebody in. What was I just saying? That gets us to now we can start diving into individually understanding about vectors, right? So now, right? Now that we know this, let's just play around and just look at vector representation, right? So a vector is a quantity that's fully described by its magnitude. By its magnitude and direction, right? So now,
We couldn't hear you, was on mute.
can you hear me now?
Mm-hmm.
Yeah, so a vector is a quantity that's described by its magnitude and direction. So now for these, right, let's look at how we represent vectors, right? We need to describe it by its magnitude and its direction. So for this one, right, for this problem, right, we have 6 different vectors, right? And so this grid, right, what does it look like to you?
Like a graph.
Like a graph, right? So a graph has also too, it would have been better if I did it like, I might add it.
X and Y axis?
X and Y, right? But also too, what city are we in? What city are we in?
We're in DC.
In DC, right? When we talk about addresses and stuff, right? And you say where you live, right? What do you have to put every time at the end of each address?
Your quadrant.
Your quadrant, right? So now look at these figures, right? What do they look like?
Quadrants.
Quadrants, right? So now it's not only a graph, but we have different quadrants, right? So relating it to now quadrants, which we even see in DC, right? You have 4 quadrants, right? And so we have our first quadrant. If I start over, can you see my mouse?
Yes.
So if I start in this first quadrant right over here, this is what I would call quadrant 1, right? This reminds me, if I'm looking at a map of like DC, what quadrant would this look like?
Which one?
Southeast.
Right here on my
Three.
mouse. Say it again.
Southeast.
Up here. Oh, sorry. It's in Southeast. I meant what my mouse is. I just look at the quadrant, not the arrow. Look at my mouse.
Oh, northeast.
I would say east. East
Yeah, Northeast. Good. So that's like if we live in Northeast. So that's like over if you were in the Lamont Ridge campus, right? And then this one, we see where my mouse is. What quadrant is this? This is the second quadrant, but this reminds you of what?
Northwest.
Northwest, where UDC is located, right? So if this one over here is Northeast, this one over here is Southwest. Now this one last right here, what quadrant this remind you of?
just the east.
This one at the bottom.
Yeah, east. Southeast.
Over here. South.
Number 3, southeast.
No, look at my mouse.
Oh, southwest.
Southwest, right? This is like we at north, right? Now this one finally gets the arrows over here. So what quadrant is this last one?
It'll be southeast.
Southeast, right? So we got northeast, northwest, southwest, southeast. Now we can represent it as quadrant 1, 2, 3, 4. Now how we're going to do this, right, is we have to relate this now to some type of math, right? So if you could angle it, right, you would think it's each quadrant is a range, right? How many degrees are in a circle?
360.
360, right? So if I was to cut this into 4, how many degrees would be in each quadrant? Technically, right?
180.
Exactly, right? So that's what we get these, like, if you look at a circle, right? If I could draw it, like you would get like this nice little right triangle right here. It's not a triangle, I mean a right angles right here. You get 4 right angles. That's where we get the 360 from, right? So at each point, right? So if I start all the way over here to my east, right? And I go counterclockwise, I can start to represent the direction based off of angles, right? So if I start here, which angle do you think this is? If it's from between 0 and 360, and I start here, which angle do you think this would be right here at 100% east?
I don't understand.
Like the
I have to
starting
get
point,
between, yes.
1 or 0.
Say it again.
You start at 0 or 1?
Exactly. Start
Okay.
right at 0.
0.
So
Okay.
100% east, like it's nothing else but east. Where my mouse is right here, this is 0.
Okay.
So now if I was to go 100% north, which would be up here, which angle do you think that is?
90.
Exactly. So that's 90, right? Now let's go 100% west. Which angle do you think that?
It's 0.
Now let's think about it. 0 was east, right? I just 0, then I went 90. And now if you think about it, I go another.
You just add 90 to 90.
So it's 1 something. It's not 180.
That is, you're right. No, it's 180. So think about it. 0, which is 100% east, is over here. And you have 90, which is north. And then west is 180. Right here on the opposite side, 180.
Okay.
Now, if I want to go south, which angle is that?
That's another 90.
So then that's how much?
270.
Correct. So now we had 270. Now, if I want to get back to my original starting point, which angle would that be?
The east, the 0.
But I was just at 290, 270, and I want to get to this next one. I add another 90, so I'm at what?
The full circle, right? 360.
Exactly. So now I go 0, 90, 180, 270, and then I'm back here at 360, which is also 0. So that's my starting point. So that's how we get the full loop of the circle, right?
Yeah.
Now let's just think logically. I know this is a lot, right? But this will help you really understand it or how it's moving forward, right? So now we're doing this, right? Say I'm in my first one, right? What quadrant is this arrow in this first one?
Northeast.
Northeast, right? Now give me the numbers, right? So if it's in northeast, right? What angle did we say this was 100% east?
0.
And what angle right
360.
here? Or 360, yes. So let's just start with the first one, 0, right? And what angle is this one here? You said this is north?
It's 90.
So now you already decided that this direction is northeast, right?
Mm-hmm.
So now numbers wise, right? It has to be in between what numbers, this type of angle, right? Between this vertical, this horizontal line and here. What do you think it has to be between what two numbers?
90 and 360. I mean 0 and 90.
Exactly, 0 and 90. So you have to make an estimate, right? Make an estimate of what you think this number would be.
45.
That's fine. 45 is fine. But do you see how you had to logically think about it? I'm not really caring about too much of the number, but do you see how you logically think about it? Okay, that looks like it's in northeast or the first quadrant. So for it to be in the first quadrant, it has to be between the zeros of 0 and 90. So I'm just gonna make an educated guess on the number 0 and 90, right? I'm not gonna get into right now because I could get into like, acute angle versus obtuse angles and like really kind of break it down. That would be helpful, but I'll try and keep this as general as possible. So when it comes to doing the numbers, but you just said about 45.
Yeah, isn't that an acute angle?
This is an acute angle. So acute
Okay.
angles are between what numbers?
0 and 45.
0 and
Wait, I think an acute angles, it's not 65, it's 40. I don't remember exactly, but it's around 45.
but think about it, right? You just said in this first quadrant, right? 0 and
90.
yes, because if it was 90 degrees is what type of angle?
That is a right angle.
A right angle, right? And a right angle would be 100% what?
90.
90, but in this diagram, right? 90 is which direction?
It's north.
So 100% north would be 90 degrees, right? So that's a right angle. So anytime you see a right angle, you would think 100% north, right? Now, what do we have? Obtuse angle?
The west.
West, or you could say angle that's what? Bigger than
180.
Bigger than what?
90.
90, right? So anything that's obtuse will be an angle that looks like which one?
Uh, 2.
2. Yes, I am kind of give you the answer. But why I'm saying that is because look at it, right? If we say 0 is over here in east, right? So we want to measure the angles counterclockwise by how we travel along the axis. So if I start 0 right here and I look at this angle from here, follow my mouse here, and then this is the vector, right? What type of angle does that look like? Acute, obtuse, or right?
Which one?
Number 2. I'm kind of moving my mouse.
If you start from the 45?
I start from the 0 and I go this way.
Oh, yeah. So that's because it's wide open like that.
It's obtuse, acute, or right angle.
It's obtuse.
Obtuse, and obtuse angles are bigger than,
Right angle.
but they're between. Yes, they're bigger than right angle, so they're going to be bigger than 90, right?
Acute. They're between acute and
No, you was right. You was right the first time. You was right the first time. It's bigger than 90. So now we have an obtuse angle that's bigger than 90, right? So now, what quadrant is this also again?
the first one
Sorry, the second one.
or the second one.
Can you see if I draw right here?
Mm-hmm.
Are y'all seeing this?
Yeah.
This green?
Yep.
All right, hold on. This will make it 10 times easier. Can you see this now?
Mm-hmm.
Okay. So I'm tracing it, right? That's the angle I'm at, right? What quadrant is in? And now let me write it here, just so you know. This is northeast. I've said everything, right? But like now let me I couldn't figure out how to draw. But this would make more sense visually. This look like DC, right?
Mm-hmm.
So now we go here, right? Remember what I said? 0. $90, right? What's this one?
180.
Good. So what's the last one?
270.
Good. And then if I was to get back to over here, it would be 0 or what?
360.
Good. So now with me having this breakdown, right? This one right here over here in number 2. And what quadrant is it in? The first, the second, third, or fourth?
The second.
The second. So which general direction is that? Northeast, northwest, southwest, or southeast?
It's north.
North,
West.
northwest, right? So now it's in the second quadrant, it's northwest. Now, numbers wise, what two angle numbers is it going to be between?
1 and 2.
So what numbers are those?
90 and 180.
90 and 180. And just math wise, what type of angle is that if it's between 90 and 180?
Obtuse.
An obtuse angle, right? So now you have to make an estimate of what you think that angle would be. This part is not the most important part. So give me just a number, right?
70.
Between 90 and 180.
Oh, 90 and 180. 120.
So you could say this angle is about 120. All right, let me do one more, right? But I want you to mathematically think about how it's supposed to look, right? So now let's do this third one. What quadrant do we think that third one is in? 1, 2, 3, or 4?
4.
4. So just direction wise, what quadrant do you think that is? Northeast, southwest, southeast,
Southeast.
southeast, right? So now numbers wise, which two numbers is it between? Let me add this right here too.
270 and 360.
360. So what do you think that angle number right be? Give me an estimate.
270 and 360. I say 300.
300. Okay, that's fine. Now we'll get into how you can estimate one, but like which one is closer to, but like 300 is fine because in between those, right? So now let's do the last 4. 3. What about that fourth one, right? What quadrant is that? 1, 2, 3, or 4?
3.
3. Now, directional wise, what quadrant it is in? Northeast, southwest, northwest, southeast,
Southwest.
southwest, right? So what two numbers is it between? 180 or 270?
180 and 270.
All right, my fault. That was a bad way to ask that. Yes, 180 and 270. So give me an estimate of what you think that angle is.
180 and 270. 220.
220. I'll take that one, right? Go to 5. Let's go to the next one. What quadrant is it in?
Northwest.
Northwest. Yes, northwest, right? So northwest directionally, and number wise is 1, 2, 3, or 4.
2.
2, right? So it's between what two angles? 9. I'll give you the answer. What two angles is between?
90 and 180.
90 and 180. So give me an estimate of how much you think that angle is.
160.
160. Good. Okay, we getting it now, right? Last one. 6. What quadrant is that? 1, 2, 3, or 4?
3.
3. Directionally, what quadrant it is? It's northeast, southwest, northwest, southeast.
It's southwest and it's between 180 and 270.
Good. And that angle should be about how much?
180 and 270, I would say about 215.
215. Okay, that's fine. Now, why I say that's fine is because now let's look at what they gave us, right? You actually got 4 100% on the dot. They put it at 220, right? I didn't do too much about the magnitude because the magnitude was based off of a scale, but that's fine. They gave the magnitude, but look at really the angle directions, right? The first one they said 28 degrees, right? 28 degrees is still between 0 and 90 because we're in this first quadrant. Then we have the second quadrant. We have an obtuse angle, which is 105. So that's what they gave us for that one, right? The last third one, we have 340. It's a little bit closer to 360, which makes sense. So you got 340, but that's still in southeast between 270 and 360. The last one you got right in the nose that they said was 220, which is fine. Between 180 and 270 for the third quadrant. Then the next one, we have the second quadrant, which is northwest, which is between 90 and 180. And they got 163, which is a little bit closer to the 180, right? Then the last one they said was 250. It's in the third quadrant, so it's between 180 and 270. Now that 250 comes because Y is closer to the 270. Now remember that when we get into really talking about vectors. But any questions on that part right there? I'm checking the chat too. This is just the start. I know this was a lot, but this is the start of us really understanding how to relate what we see visually with what we see mathematically with understanding vectors. Okay. Now let's move on to understanding what vectors, how we even add them together, right? So now you add vectors together from end to end to create new vectors, right? So like in this first one, right? We're trying to see which vectors add up to the other one. So we have 2 vectors that's going to add up to a third vector. And that's what I meant to put. I meant to put a definition. So the resultant really is the addition of 2 different vectors, right? I'm going to have to add that. The resultant is a division of two vectors together. So in this exercise, we want to determine which vector is the resultant. So we have 3 vectors, A, B, and C, right? Basically, which 2 vectors add up to the third vector? So if I was to look at it, right? I'll start with the first one. I'm looking to see which 2 vectors, if I travel from end to end, will give me the third vector. 1 second.
A and C.
First, go ahead.
A and C.
So let's start from end to end, right? If I start from A, hold on, I can actually trace it.
No, it would be C and B. No.
You are right. Go ahead. No. You were right with that, just right there. So let me do it, right? Let me do C, and I'm gonna go end to end, right? So I'm starting here, right? This is C, and I'm traveling, and I'm going to B. Then from the end of B, then from the end of B, I go to here, and I get to A, right? So if I follow this path, remember how we talked about displacement? What's my actual displacement?
C.
Not the name of the vector. Let me draw it for you, right? So green is my distance of how I travel, right?
The displacement is black.
Black, or if I do this, is that not my displacement?
Yeah, A.
So now let's think about it, right? The resultant is which one now?
A.
A. So now we got A as the resultant. Now, if I was to create an equation, right? This vector plus this vector equals this other vector, what would it be?
Would
Now
it
let's
be-
talk about the path.
Would it be A plus?
You can remember what I said. A is the what? The
Oh,
what?
no, that's the resultant. So it'd be B plus C equals A.
Now think about it. Yes, that is right. B plus C equals A. But also for this right here, because we think about you following like a Google Maps, right? The order matters, right? You got to make a left turn before you make a right turn, or you'll be somewhere else, right? So how should the order be to make sure we have the right vector?
Oh,
said
like
what?
C plus B instead of B plus C.
Yes. So
I'm
now
confused. What?
hold on. Addition is cumulative, right? You can switch it either way, right? But for these vectors, it kind of doesn't matter the order that you go because it'll show you where you have to go end to end, right? So you said B plus C equals
A.
A. Now let me do that. What you just said, right? Hold on. In green, I'm gonna go from N to B. And let's say if I did add C, right? But I would have to add it B here. Now C is this one right here, but because you said B plus C, I really would have to start C this way. Technically, I just proved you right, that you were actually right, because now my resultant is still this. So it still was fine, to be honest with you. But it does look a little funky, right? So I did just do B. I actually just proved you right. B, N to B here, and then I added C, which is this one over here, but I had to make it from this end here to where I still get the same result, which is this A vector. So it's fine, right? But just for this exercise, let's just go in order based off of how we see it so we don't confuse ourselves. So what would the equation be instead of B plus C?
C plus B equals A.
Yes, just so we can follow it. We have C, then we have B, and then we have A. So now the vector equation, one more time, C plus B equals A.
A.
Now, at the very end, right? So we got this new vector, which is our resultant, right? Remember, we have our axis. I'm going to draw the axis in green. Remember this axis? Now, what's the direction of our resultant that we have based off of that axis?
2. I meant quadrant. I would say quadrant 2. I meant quadrant 1. Sorry, northwest.
Hold on. Quadrant 1, which is
Northwest. Northeast. Sorry, northeast.
northeast. So it has to be between what two numbers?
0 and 90.
0 and 90. Just give me an estimate.
65.
Okay, we could say 65. It might be a little bit less, but I'm gonna just go just because you gave me 0 and 90. That's fine. All right. So now let's do that again, but for all of them, right? One more time. We got 2 more.
Then you would have. Would it be A? Would it be B plus C equals A again?
Yes. Yes. So then what is the resultant?
A.
A. So you got B plus C equals A, and then give me a direction.
Northwest. Northwest.
So it's between what two numbers?
0 and 180.
0 and 180 or
90 and 180.
I'm sorry, 90 and 180.
90 and 180. I'll help you out right here. Give me an estimate of where you think that's at.
90 and 180, I say 170.
Okay, you said 170. That's fine. At least that you got me to Northwest. I can do with that, right? Do me get the last one.
The last one will be B. It would be A plus B. No. It would be B plus Man, is it B plus C equals A again? No.
Trust yourself. Go back to the first thing you said. Let's look. You just said A plus B, right? Look,
Yeah, A plus B
A.
equals C.
plus B. If I switch this color, that's my distance traveled. Now, what's my displacement?
C.
C. So the equation is A plus B equals,
C.
which means my resultant is.
C.
So now give me,
It's in the southeast and
hold on, for me start from here, right?
oh, okay.
Now where is it at?
It's in northeast. Sorry, northeast.
So give me an angle.
0 and 90.
Give me an estimate.
0 and 90.
Like 30.
39.
That's fine. Yes, I both said around the same. So now, hold on. So for the first one, we got the resultant right, A. So we got C plus B equals A. And then we added from tail to tail. So then you said like 60 something, but like 20 gave us about 20. But you still got between 0 and 90 was fine. I think for the second one, you was closer because you said about 170. They gave 165 for the angle. So you was in the right around ballpark with the quadrant. And then we got the equation, right? B plus C equals A. Really going to end. That's why we're kind of doing it like that. And with A being the resultant. Then the last one, we got the resultant to be C, which is A plus B equals C. And then approximately, y'all both said around like 30, right? So do you see how we kind of putting all this together to kind of like you add vectors and putting it like together and then creating and finding direction with the resultant?
Mm-hmm.
Good. All right, so let's keep moving, right? So just the key concepts that we want to go over, right? A vector component is the effect of the vector in a given direction, right? So in 2 dimensions, right? Vectors usually have a horizontal, an X, and a vertical component, Y. Horizontal components can be described using X or how we usually know in like quadrants and like direction, like compasses, east, west. And then we have vertical components can be described as using Y or north, south. So now let's go ahead. So now let's take all of that, right? And let's put it together to where we want to determine the direction of 2 components and indicate which one has the greatest magnitude. So remember, vectors, quantities are ones that are described fully by magnitude and direction, right? So looking at this first one, right? They got it all sketched out to us, right? Now that I've got the drawing thing, right, I'm going to draw it together with red, right? So they got us, and we want to identify which component which have the greatest magnitude. So now let's look at it, right? I'm going to draw it over to the side just so you have reference in green, right? We got our quadrants. They got it as north, south, east. It disappeared. Sorry. I can see this, right? Can you see what I'm drawing?
Mm-hmm.
All right. So now we have these, right? These are the same numbers that go along with it, right? This is north, south, east, west, quadrant 1, 2, 3, 4. So now, if I was to draw one, right, and I'm still going to even add these, northeast. This is a lot, I'm not going to lie, but it's very necessary. South. East, right? Okay, I did my best. All right. That is a lot on the screen, but just do this as a reference. For this problem, right? The first one, they said 45 kilometers at 300 degrees, right? 300 degrees, what quadrant is that? 1, 2, 3, or 4?
4.
4, because it's between what two angles?
270 and 360.
Okay, right? So now let's think, right? It's in between 270 and 360. Now, how would I draw that? And why I'm asking that is because which angle is it closer to? 270 or 360? Numbers wise.
360. I'm sorry, 270. It would be closer to 270 because it would
70,
be
right? So think
Yeah.
about like location wise. Should I draw it closer to the S or should I draw it closer to the E?
the E.
The S,
Because which one is it closer to?
because
The
it's
S.
closer to the S, so it should be near the S.
The S, right? So let me try and draw a line close to the S, right? Oh, that was off. Hold on. So I'm gonna draw it closer to the S, right? So now let's think about it, right? What components do I have? I have the S and I have the E, right? Now, based off of what I just drew, which one is it closer to, the S or the E?
The S.
So which one do you think has the greatest magnitude to affect for that resultant, the S or the E?
The S.
The S, right? So that's all this question is asking. Figure out the components and tell me which one has the greatest magnitude. Now you said this one has the S because it's closer to that one, right?
Mm-hmm.
All right, so let's do the same thing for the next one, right? 265 degrees, 10 kilometers, right? Which quadrant is that? 1, 2, 3, or 4? 265.
Four.
You was right the first time. 3.
3.
Right. So now directionally, what is that?
Southwest.
Southwest, right? So it's 267. Which angles is between? If it's southwest.
West and southwest.
West and south, right?
So what, 180 and 270?
Yes. So now would it be in 260? Which angle is it closer to? 180 or 270?
270.
So now where should I draw my angle? Closer to the W or closer to the S?
Closer to the S.
So let's do it like that, right? So I'm gonna start in the middle and I'm gonna go more so like this, right? So now if I think about it, I have my components S and W, right? Which one do you think has the greatest magnitude?
S.
The S, because it's close to the,
S.
there we go. So that's what we're going. So let's do the last one. You tell me what the last one.
It's 200. So it would be close.
Hold
to,
on. 200 is the what?
I'm sorry, it'll be close to 150 degrees.
150, because it's 200 miles at 150 degrees. Now, what quadrant is that in? 1, 2, 3, or 4?
2.
2, good. So it's between what two angles?
90 and 180.
90 and 180, right? So now would it be in between 90 and 180? You know, it's 2, and it's closer to what? 90 or 180?
180.
180. So where should I draw my arrow?
Closer to the 180. Closer to the W.
So let me do that. So now I have N and W. So now, which one has the greatest magnitude?
The W.
Good. Make sense? Hold on. All right. Oh, what's up? You okay? You okay? All right. So, with me doing that, right? Now, this is the part where we're going to get into some math, right? Some of y'all might hate me after today, right? So I'm bringing you back to trig. Anybody remember trig from algebra 2?
No.
All right. Well, we're going to learn some trig today. Now, trigonometry, right? A big part of trigonometry is using trigonometric functions, right? And they are used to find the length of the sides of a right triangle, right? So over to my right, I took this directly out the practice problems, right? When you got a right triangle, you can always identify each right triangle by having 3 sides, right? So the first side is going to have, or first 2 sides are going to have opposites. Well, let's talk about the first side. The biggest side, the longest side is always called the hypotenuse. So whatever the longest side is in a wrong triangle is called the hypotenuse. Now that you have an angle, which when you look at it, right? So that angle that's in right here where my mouse is, opposite of that angle, we call that the opposite side. So the side opposite of that angle, we call that the opposite side. Then the side that's closest to it, we call that the adjacent side. So we have those 3 sides of a right triangle: the hypotenuse, the opposite, and adjacent side. Now, because we understand just how right triangles work, we could actually find out the angles and the values of any side in a right triangle if we just have like one or the other. So if I know the hypotenuse and I have an angle, I could figure out the opposite and adjacent side. Bless you. So or I can play around and do the other things as well. But we have to use this mnemonic, which they talk about, SOHCAHTOA. Who's heard of SOHCAHTOA before? There we go. I'm seeing some likes, right? Now, that's just how you remember it. But what it actually stands for is sine, cosine, and tangent, right? These 3 trigonometric functions are used to be able to help find the 3 sides of a triangle, right? Or even the angles, right? And the SOHCAHTOA mnemonic really comes to help you understand which they represent. So sine of an angle, which I have right here, is the opposite side. The sine of an angle is equal to the opposite side over the hypotenuse. So on my calculator, right, where it says like sine, S-I-N, and then if I put the angle number, that is also equal to the opposite of the hypotenuse. So if I know the opposite of the hypotenuse, I can find the angle over side of that triangle, right? The angle in that part. Or if I know the sine and the angle, I can find one of the 2 sides that I'm missing. Same thing if we have cosine, right? Instead of it being opposite of hypotenuse, I just switch it to being adjacent of hypotenuse. And the last one, tangent of the angle, is equal to opposite over adjacent. Now, just remember SOHCAHTOA and you'll be good. Now let's actually use it instead of me just talking about the math, right? So now when we have this, I wrote in the top right or review, right? We have our 3 equations: SOHCAHTOA, sine, cosine, tangent, right? Now this is the same problem we just did, right? But now let's look at it and determine the magnitude of each component using now the trigonometric functions, right? So there's gonna be some math involved, right? Okay. Let me make sure I have my calculator ready, right? I'm gonna do the first one. I'm gonna have to really draw. Hold on. All right. Let me do what I just did earlier, right? We got 45 kilometers at 300 degrees. What quadrant is that? First, second, third, fourth?
Fourth,
Fourth, right? It's between what 2 angles?
south and east,
South and east. So the numbers is what?
270 and 360.
Good. So because it's 300, is it closer to 270 or 360?
270.
So I'm gonna draw my line a little bit closer to the S or the E.
That's
All right. So that's what I'm looking at right now. Now, what I'm finding what I'm trying to find now is asking me, look at what I'm about to draw in blue. It wants me to find these 2 components. Remember how we did vector addition? This is what it says. So this is east and west. Actually, let me make the second one a different color. I'll make it green. Oh my gosh. So let's say my east and my west component or my horizontal is in blue and my north and south component is in X, right? I mean, it's in green. We want to find each one of these individual components, right? So now what I have to do is take this out. You see what I just created? I actually created a right triangle. In black over here, I'm not going to do black. I'll just do the same colors. But I'm going to turn it to where you can see it, right? So say this is my original vector, right? And it's created by these two components. Blue, green, right? What shape does that look like?
A right triangle.
Right triangle, right? Now let me just take the values and add them to it, right? This 45 is our resultant. So now this number is actually, this side is 45. Now, when we measure our angle, right, we measure our angle based off of the horizontal line at 0 and then the angle in between, right? So now it's at 300, right? So all of this is 300. So just hold that and just know that that whole entire angle is 300, right? Now, but we're looking at this little bitty angle right here. So we have an angle here, we have an angle here. Now, what are we trying to find? We're trying to find this X, this part, and this Y. Right? Now, when we talk about it, we can describe it in which kind of fashion, though. From this angle, that's in red, right? Is this side right here my adjacent or my opposite?
It will be your which one? Which side?
Blue. Is the blue my adjacent or opposite?
It would be the opposite. Well, the adjacent is the adjacent because the Y is the opposite.
Good. So this is the adjacent, right? So then the Y would be the, like you said, the opposite. So now to find our east and west or our X component, right? Which equation will we use? We have our hypotenuse and we have our angle. So we need to use which one?
The cosine, the co.
Good. Cosine. So how would I set it up, right? Let me do it up here in black. I'm going to do cosine. And what's my angle, right?
Uh, 45.
Hold on. 45 is the what?
45 is the length. The angle would be 60.
Good. I'm glad you said that. I'll come back to this. So the angle is 60. And then, oh my gosh, my spacing is terrible. It's opposite, it's adjacent over hypotenuse, right? So do we know what the adjacent side is? Do we know that yet?
No.
No.
No. So I'm going to just leave it as A because we don't know. But do we know the hypotenuse?
Yep.
It's how much?
300.
That would be the angle. Remember, we just said the angle, right?
45.
45. That's the hypotenuse. Good.
I thought the angle in that problem.
Hold on.
was-
Yes. I'm about to show you. Just stay right there. You're not wrong. I know what you're about to say.
Okay.
All right. So now, to solve this, right, this is a one-step equation. Let me rewrite it a little bit neater over here. Cosine 60 equals A over 45, right? One-step equation. We see what on this side? What operation do we see?
Division,
Division. So if I want to solve this, I have to do what?
60 divided by 45.
If I see division, I have to do the opposite to get the answer.
Multiplication,
By how much?
45.
So I multiply each side by 45. So on your calculators, right, do 45 times the cosine of 60. And what do you get?
Um, 6 times 4 is it thousands? 28,300?
Cosine is 60. So did you press 60 and then put in cosine?
Oh, no.
You on your cell phone?
Yeah, I didn't hit cosine.
You got an iPhone?
Mm-hmm.
Do 60 and then press the COS.
Okay. Let's see.
And then once you get that number, tell me what number you got when you did 60 and then press COS.
Okay, I'm about to do it right now. I don't even have a COS. It's just the AC plus minus percent and division. I don't have all that on this.
I
iPhone.
think if you turn your phone to lengthwise, it'll come up with all
Yeah.
the extra ones.
To do what?
Turn your phone to the side.
There's,
Oh.
there's also like a little calculator at the top. If you change it to scientific mode, you'll see the cosine.
Okay. So I do 60 times 45 cos.
Hold on, no. 60 and then press COS, COS. Like press in 60 and then just press
0.5.
0.5. Good. Now multiply that by 45 and you get what?
22.5.
22.5. Good. Did everybody else get 22.5 that did it on their phone? All right, good. Now, so that's our horizontal component, right? Now, let's do the same thing, right? Now, if the horizontal component, we had to use cosine because we did adjacent of our hypotenuse, what side are we trying to find for the north, south, or vertical component?
What? So you said it again?
We wanted to find the horizontal component, right? That was X. So then that's really technically A, the adjacent side. We want to find the Y, which is the vertical. Technically, which side is that? Is that opposite or adjacent?
Opposite.
So now if we want to find the opposite, which equation do we use? Sine, cosine, or tangent?
Tangent.
Technically, we could use tangent, right? Because we just found adjacent. But for this one, I want you to use the other one.
Adjacent and hypotenuse.
Other one.
The sine.
Yes. Only because when we're doing these type of problems, always go back to what we're given before you start using what you calculated, because you might make a mistake in the one that you calculated and you don't want to use that to find the other one and then you'd be all messed up. So always go back to what you were given. So they gave us 45 and we had an angle. So let's use that again to find the opposite, which will require us to use sine. Now you set up the problem the same way, right? So we still got this angle. We said this angle was 60. And we're trying to find the opposite. So if I start off with sine, all I'm going to really do is just this sine and then put now the angle being 60 and then set it equal to the opposite over 45, because the opposite is the unknown side and we have 45. Now I see what operation?
Division, so you multiply.
Good. So now I'm doing the same exact thing. The only thing I changed was the
It's
cosine.
sine.
So now do the same process. Do sine of 60.
So 0.87.
and then multiply it by 45.
38.97.
All right, hold on. What I meant to say? Give me 1 second. I'm about to change this real quick. Take a screenshot of this if you want it, and then just like it when you're good. Because I'm about to go back real quick. As soon as I see somebody like that they're good, then I'll get rid of it.
Okay.
All right. Let me stop sharing for 2 seconds. Say the number that you said again.
I knew what was wrong when I said it. 38.97. Is it 39?
No. That's fine. All right. Now, just 2 seconds. All right, cool. Now, all right. I think it was Izeli, right? When I drew this out, right? Real quick, Izeli, if you don't mind coming off of mute. When I drew this out, I had this angle here. And then when I drew my triangle, I had it as here with, switch the colors. And then when I identified that this is a right triangle, right? I said that we given an angle of 300, right? But Izeli, you told me to use what number instead of 300?
60.
Why did you say use 60?
The angle on the inside of the triangle would be 60 because it's like the whole of it would be 360, which is like the degree of a circle, and you only need the angle on the inside.
Good. So I'm glad you caught that, right? So Lakshmi, this is me getting to answer the question that you were about to say, right? Now, to use these problems, right, you would just use the angle that you have, and I'm about to show you why in a second. But you want to think about it logically so we could really get out of, what is it called? Formula fixation. So where we're just using the formula and just remember, I know. I want you to actually look at the problem visually and try and look at it from the shape aspect. So when we have a vector, it can be pulled out by its individual components to create a right triangle. Now, with us knowing that, we can use this to help us figure it out without having to do as much math as possible, right? Because if I do 300, I have to actually plug that in the calculator. But what you'll see later on in class, if I can figure out how much it is by using these three, I can find 60. And I'll show you later like how there's shortcuts to be able to where you can do less math. But you have to think logically of what it looks like when you pull it out, right? And then also too, just remember with shapes, right? A circle has how many degrees?
360.
What's the maximum amount of degrees in a triangle?
180.
180.
180, right? So when we're looking at a triangle, we can't look at it and say, oh, 300 and it'd be degrees and it'd be like, oh, okay, that's a triangle to that. We have to actually find how much it is relative to the 180 limit in a triangle. So if we know it's a right triangle, one of the angles has to be equal to how much?
45.
Hold on, close. If it's a right angle, right triangle,
90.
90.
90.
Right? So one is going to be 90, right? So now how many degrees we have left in the overall triangle if one of them is 90?
90.
90 in total between two angles, right? So Izeli just found out that this one, because this little circle part right here, right? If we wanted to make a full circle just on this little axis right here, right? Let's say I make a little axis. They told us that this is already 300. And to make a full circle, we need this remaining part right here. We know a full circle is 360. So we do 360 minus 300 to find out this is 60, right? So if this one is 90, this one is 60, how much is this last angle?
30.
Say it again.
30.
30. Now we have our full right triangle. Now remember this 30, 60, 90 triangle is going to come again. But now that we know this, right? We use 60. Let's see if we get the same answer if we just use the formula and plug in 300. So to find this component, we used cosine. So instead of me putting 60, let's put in 300 this time and see if we get the same answer, which should be 22.5. So actually, let me write it over here. Cosine 300 equals opposite over adjacent, which say adjacent over hypotenuse, and the hypotenuse is 45. Then I'm gonna set it up the same way here. We did sine of 300 equals opposite over 45. If I see division, I do what?
Multiply.
So now all we're going to do is multiply 45 by the cosine of 300 and 45 by the sine of 300. Do it real quick and tell me which numbers you get. Basically, really, do you get the same answer? You should get for the first one 22.5, and for the second one, you should get around 39. And if you get that, let me know. What are we looking like? Well, actually, since you asked, Lakshmi, what did you get for the first one? Did you get 22.5?
Yeah.
And then for sine, did you get, what number did you get?
Like 39.
Okay. So do you see how we were able to use 300 and 60 and get the same answer?
Yeah, I see that.
And so does that answer your question?
Yes.
Okay, cool. All right. Now, the answer might be no, but that's okay. Now I'm about to put you in the breakout rooms and split you up into two teams. And all I need is the same process for you to do for the second one and third one, right? So I'll make the rooms real quick. And we really want to take literally literally 4 minutes. I don't want this to be math heavy. I want it to be like 2 seconds. So you have like 4 minutes. At 7, I'm bringing you right back. 10 kilometers at, this is the problem you have, 260 degrees. It's at the top when you go in the breakout room. And then,
Professor, my bad. I'm sorry. I got to head out. I got some family stuff.
that's fine. I'll see you next time. And the recording will be on YouTube.
Perfect. Thank you.
At 150 50 degrees. So I'm splitting you up. Now it'll be 3 minutes. I'm only gonna give you 3 minutes, right? Literally, you could screenshot what I just have right now, but take 2 seconds to just go through this, and I'm bringing you back, and I just need an answer. 3, 2, 1, go. Wayne, join the breakout room real quick, or did I give you one? I did not give you one. Oh, I did. Let me see if I can just put you in there. Did you mean to come back?
Yes, my connection is bad. It kicked me out of the meeting when I was trying to join the breakout room.
You still should be assigned. Hold on real quick. Do you join again, or do I have to assign you again?
Oh yeah, I see one.
Yeah, just join again.
Mhm. Let's hope it makes me join. My connection is bad.
All right. All right. Now, if you struggle, good. What we're going to do is we're going to talk through it together, right? All we really need 2 people from each group to come on because the groups are kind of big to kind of just give me what I'm looking for. So I would love it if somebody could walk me through at least 2 people could walk me through the east component and the north and south component and tell me what equation I'm putting in my calculator and then giving me the answer. So can I get that from the first group who was the 10 kilometers at 265 degrees? Can somebody give me from that group, just talk me through the east-west component, how I'll find it.
Would that be the cosine of the angle?
All right, so you got cosine of the angle. Hold on. Bless you. Cosine of the angle. And that equals cosine of the angle. What is the angle?
265.
So we did 265. And that's equal to what?
That is minus 0.08.
Okay, minus 0.08. Which, go ahead, keep going.
Is that because it's like on the left side of the number line or whatever?
So think about it. Yes. Well, hold on. 265. Yes. So think about it. What quadrant is it in?
That would be the bottom left quadrant.
So now we're talking about it, right? If we say east is positive, that means west is.
Yeah, negative. Okay.
So now we're talking, okay, we're so bottom left, right? So we have negative, you said point whatever, right?
Yeah.
Well, on its right side, right? Cosine is equal to what from the equation?
Adjacent side divided by hypotenuse.
So let's say we're trying to find the east-west. Let's say that's the x, right? What is the hypotenuse?
The 10 kilometers.
10 kilometers, because that's actually the resultant variable. So now I'll put 10 in the bottom, right? So you just got this negative number, this negative blah, 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 right?
Mm-hmm.
I would have to do what with that?
You just have to multiply that by 10.
And you get what?
Negative, like negative 1-ish.
Okay, so we get negative 1-ish, right? But what does that really mean directionally?
It's just the component to the west is 1 kilometer.
Exactly. So now we have 1 kilometer to the west. Sorry, I had muted myself. Could somebody else from that group give me the north and south component, how you'll find it?
Is it group 2?
What is it? The
The
we're
middle
doing the
one?
10 kilometers one.
Yeah, so for north south we're using sine 265.
And what else?
So it's opposite or
Opposite over what?
hypotenuse.
So I'm gonna just put y because we know we're looking for the vertical component.
Mhm.
And then how much is the hypotenuse?
10.
10. So I'm gonna put it over 10. So now we do what?
And 10 times sine 265.
And you got what number?
Is it negative 9.9?
You got negative 9.9. Now, what does that really mean directionally?
Is it going south?
Exactly. So the negative really shows it south because we established that north will be positive, south will be negative. So when we see negative in the y component, that means we're going south.
Mhm.
So then positive and negative, remember, they just tell us about direction. So now when we see that negative related to cosine and sine, we know negative cosine will be west. Positive cosine is telling us about east. A negative in the sign is south, while positive in the sign is north. So on this last one, right, we already established in the previous problem that this was southwest. Now we have the math to kind of back it up. That is going to be in the southwest quadrant. Now for that same thing, let me get the same. Did you just hear what the last thing I just said, or was I on mute?
I think it's on mute.
So when we notice, right, we have positive and negative, right? So we have for cosine, right, a positive in the cosine would be east versus a negative in the cosine represent west. A negative in the sine would represent south, while positive in sine would represent north. So that's how we know with this one, we both got two negatives in the cosine and for the sine, to where we notice the quadrants would be southwest. So that's how it relates to the previous problem we did. All right, let me get two more people for the last group who did the 200 miles and 150 degrees, right? So if somebody can explain the east-west component and just tell me what I'm writing.
I'll explain the east-west. So for hours, I said it was between, in quadrant 2, so it was northwest, because it's between 90 and 180, and it's 150.
Good. So we established what quadrant is in. It's one northwest. It's between 90 and 180, so it's 150. Now let's find out how much the individual components are. So what you're doing, east-west, we want to actually find out what is the east-west component. So which equation would I use? Sine or cosine?
We use sine.
Let's think about it, right?
Use cosine.
Let me use, well, go ahead.
Use cosine because it's on the x-axis, and that the east to west is on the x-axis.
So for east to west, yes, we want to use cosine because we want to find, let me draw it out. We want to find this one and this one. So then that's our triangle, right? So now when we pull out our triangle, we know this one is 200. We know that this angle all the way around is 150, right? So if this angle all the way around is 150, right? This angle from here to here, how much is this little angle right here?
30.
30.
It'll be what?
30. So let me rewrite this.
I don't understand why would it be 30 if you did 360 minus 150.
So,
Go ahead, Izeli.
so you can like see the little line right underneath the 150 and then the angle, so that he's only including like the upper half of the circle basically. So that's just half a circle, not the whole circle. Because we did the whole circle, it would be the 150 plus the angles on what would be like quadrant 3 and 4.
Okay.
Yeah, like so we see where like that red line is. He basically just included the top angle, not the whole circular angle.
I keep talking, but I'm on mute. Sorry. Did you see that angle I just drew?
Mm-hmm.
So what? How much is that angle? That's a straight angle. A straight angle is how many degrees?
I don't remember. It's not 45.
Look at it. Just look at it. If that's straight,
0.
0 was on this side, right? So on this side is how much?
180.
180. So this whole red line, the amount of that angle is how much?
180.
180, right? So now we call these supplementary angles, right? So say if I got two angles right here, right? This one that we just established, this is that 150, right? So we need to find out what's the remaining part to make up this 180. So that's why I did 180 minus 150, and I got how much for this in-between one?
Um, 30.
So now I have my triangle, right? So now I got 30 here. I still know that this one right here is 200. Now I'm trying to find this one is what? Is this opposite or is this adjacent where this red marker is right here?
Which one?
Where I put this dot. Is this opposite or adjacent?
Opposite.
Opposite. So then that means this one is what?
Adjacent.
Adjacent. So now I want to figure out what this side is. So I need to use what equation? If I want to find out what the opposite side is, I use which one?
Multiplication.
Multiplication, but I have to set up a what equation first, sine or cosine?
Cosine.
If I want to find the opposite.
Oh, sine.
Sine, right? So that's what we do for the south, right? So for the south, I'm going to do sine of. Now you got two options. You can use for the angle. You can use which one?
150.
150, or you can use
30.
30. You'll get the same answer. I just put a slash so you can see it could be 30. And I set it equal to what? My opposite, which I don't know, but I'm going to call that y. And then how much is my hypotenuse?
200.
200. So I put 200 here. Now I'm going to do the same thing for the x and y. Cosine. What angle can I use? What two options?
150 or 30.
150 or 30. Or 30. And I set it equal to my adjacent, which I also represent as x. And then how much is my hypotenuse?
200.
200 again. And I do it like that. Now, what number should I get when I multiply that through?
That's for the sine is 100, and for the cosine is around negative 170. I think.
Okay, so for sine, you got how much? Say it again.
100.
100, right? And then for cosine, you got how much?
Negative 173. I think it was.
Negative 170. So what'd you say?
173. I think.
Negative 173. Now, think about what we did earlier, right? Which number has the larger magnitude, as in the number? Which number is larger? Ignore the negative and positive.
173.
173. So that one has the larger magnitude. And which component is that? The east and west or the north and south?
North and south.
The north and.
No.
Sorry.
Yep.
The 170 is which one?
East. Sorry, yeah, east west. Right?
East and west, right? Now, remember what we said earlier, right? Courtney, this what is it? This vector is between what two numbers? The angle.
90 and 180.
The zero, I'm at the 90 and 180.
90 and 180. And the angle is how much? What's the number?
150.
150, right? Courtney, is it equal? Well, sorry, which number is it closer to? 150 is closer to 180 or 90?
150. I'm at 180.
180, right? So therefore, which component do you think it would be if it's closer to we established that it's northwest. So when I draw my arrow, it should be closer to which direction? West or north?
West.
West, right? So if we say it's closer to west, which component do you think is going to have a larger magnitude? West or north?
West.
West. Izeli, what number has a larger magnitude? The west component or the north component?
The west component.
The west component, because it's 170 compared to. What was the north component?
100. Can you read this? Something big. 100.
You said 100 what? 100 what?
The north component was 100 and the west and east component was 173.
Good. The only thing we see is we see the negative, right? The magnitude, the west component is a little bit higher. But what does that negative represent? Do you remember?
Just the direction, right? Because it's the west.
Just the direction. So now we know it's in where, Lakshmi? Yeah, it's where?
The west.
The west. The negative gave us the direction. See how we putting everything together, what we see logically and just visually with some actual numbers?
Mm-hmm.
That's how they all connect. Because we know that we have a negative, we know which direction we're going, left or right, up and down, or north, south, east, west, right? Now, when we talk about magnitudes, we see how these components contribute to where it's going to be at directionally, right? So if I'm in northwest, I'm going to be more west if my magnitude is higher in my east-west component. But if I'm in northwest and my magnitude is higher in the north component, I'm going to be more north. So that's where these components come into putting it all together, right? And even in this, right, we talked about two different triangles, right? I'm gonna try and get through this so we can get out of here a little earlier. It probably won't be earlier, but let me try and make this why I have like at least you guys here at this point. Oh, let me just show the answers too. Can you see that?
Yeah, can we take like a 10-minute break?
Yeah, I got you. Can you see the answers from what we just did?
Mm-hmm.
All right. Now I remember that the first one was a little bit longer, but yes, we got 23 and about 29. Then someone just said it. You got about 1 and about 10 for the second one, yes. But the last one, right? We get into talking about those components, right? Now y'all are saying the positive and negative, and I want you to keep saying that even though it's not shown in the answer. I need y'all to have that understanding so you know where it's at directionally, right? So that's how you put it all together. But now we'll take 10 minutes. But when we come back, right, we're gonna really dive into doing this over and over again, but I really want you to catch the drift of the special triangles I'm going to show you and how it goes together so that you're not doing too much math, because if you're doing a lot of math and not thinking logically, you'll kind of fry your brains. So like take about 10 minutes and then we're going to do like 1 more hour of just going through this and we should be done to where I set us up nicely to be able to finish all of this on Wednesday. Okay?
Okay.
I'll see you back at pretty much 7:30.
Okay. Could it be 7:35 if we got another hour, please?
We're going to be out of here at 8:30.
Okay.
All right, we back. This is where we just left off, right? I came and gave you this. Move forward. Now, today is a heavy math day, but now I got to get one more math component, right? Let's put it all together. So we got Pythagorean theorem, right? So this is the concept that we put together when we do for math, right? So the Pythagorean theorem defines the relationship between three sides of a right triangle, right? So we got a squared plus b squared equals c squared. And so when we're using the right triangle, we can use this to be able to find any sides of the triangle if we have one that's two sides that we know and we're trying to find the missing side. So in relative, just understanding it, the A and B are usually the opposite or adjacent sides from what we just talked about before, and C is usually the longest side or the hypotenuse. Not usually, it's always the hypotenuse. So C is always the hypotenuse. So we can use this equation to find out any of the missing sides, right? So now, what we want to do is take this together and use all four of these equations to be able to find out the magnitude of resultant. So let's start out first. And let's just do this, right? And let's find out the magnitude of the result, and then we'll use trigonometric function SOHCAHTOA to find the direction. So let's start first. Let me do one. Now this one, I hope this takes 2 seconds to do. And if somebody sees it before me, come off mute, right? So let's say we do this, right? I'm gonna make my resultant right here, right? Because we add in, we go this way, and then we go up. So my resultant is this one right here. So now I want to find out what my R is, right? So let me pull out this triangle and pull it out over here, right? I got 3 on the bottom. I have 4 right here, and I want to find out what this one is. So if I do my Pythagoras theorem, this would be my C. So I got a squared plus b squared equals c squared. So then that would be my A. Let's just pick either one. It doesn't matter. I'll do 3 first. Plus 4 squared equals c squared. Real quick. What's 3 squared or 3 times 3?
9.
9. What's 4 times 4?
16.
16. So I got 9 plus 16 equals c squared. What's 9 plus 16?
25.
25. So I got 25 equals c squared. Now I don't want to find c squared. I want to find c. So I have to take the what?
Square root.
Square root. What's the square root of 25?
5.
5. So now I got 5 equals c. Therefore, my R, my resultant, is actually, its magnitude is now equal to 5. So if I rewrite my triangle, I now have 5, 3, and 4. My resultant, 5, and my opposite and adjacent, 3 and 4. So now I know my resultant is 5. Now, with me knowing this, right, I want to find out the direction, which means I need to find out the angle, right? Now, let me get rid of all of this. We could use 5 because we just found it, right? But if we have our triangle, right, let me redraw it to where I have it, but I don't know what C is. I know it's 5, but I don't know what C is, right? And I want to find this angle, which would be my direction. Which one of these equations can I use to find out my angle?
The tangent one?
Tangent, right? Good. So now I can do tangent. This is how I'm going to use it. Tangent. Do I know the angle?
No.
No. So I'm going to leave it as theta, which is our angle, right? Do I know my opposite and my adjacent side?
Yeah,
Okay. So really, what's my opposite from this angle?
4,
4. What's my adjacent?
3.
3. So now I have it set up like this, right? Now, to find out what theta is, right, I have to do something called taking the inverse operation, right? What does that mean? I need to take the inverse tangent of each side. So it's going to be like this: tan -1 of this, and then tan -1 of this ratio. When I do that, now I can find the angle, because the inverse tangent of an angle is just that angle. So at the end down here, I'll have theta is equal to the right side. Now the right side is an actual number. It's a ratio, right? So 4/3 is the actual number. So if I take the inverse tangent of 4/3, I'm going to get back a number out of my calculator. So what you have to do is if you want an iPhone, take your calculator. If you want to, turn it sideways and then press the second button. And once you get the second button, you should see all the inverse trigonometric functions pop up. So then I want to do 4/3 on my calculator, right? And then press inverse tangent or arctangent. It'll come up to where it gives me that, right? And then when I press it, I should get a number. For me, when I did it, I got 53 about. Anyone else get 53? Good. All right, so we got the 53. So that's the process I just went through, right?
No. Do you press, how do you do 4/3 on the iPhone?
You just do 4 and then divide it by 3. So you do 4
That's what I
divided by
thought. I just make sure. Okay, hold on. 4 divided by 3. And then press tan 1.
Yeah. Yes.
I got 71. Yeah, I got 71.56. So it's just the 4 division sign by 3. And then hit tan.
It's tan inverse. Maybe you're just hitting tan.
I don't know which one is tan.
I'm sorry, I was off mute. Press the button on the calculator that says second first, then you'll see the tan inverse come up.
I still got 70. It's tan -1, right?
Yes.
Yeah, I still got 71.56. Hey.
Did you do 4 divided by 3 first before pressing the tan?
4 divided by 3, not 3 divided by 4.
Yeah, 4 divided by 3, tan -1 is 71.56.
And your calculator is in degrees still, right?
I'm
Tan. You press TAN. Not
Yeah.
tan 8, not tan H, right? TAN, right?
Yeah, tan -1.
Okay. You keep getting 70?
71.56.
What did you get when you did 4 divided by 3?
You said I shouldn't have did 4 divided. I thought it was.
What number did you get when you did 4 divided by 3? Like before you hit the 10.
Yeah, I did 4 divided by 3.
And you got what?
I did. I'm doing it right now again for like 100 times. 4 divided by 3, and then 10 negative 1.
Hold on, do 4 divided by 3 first and just see what number you get. That's what she's asking.
Oh, it's 1.3.
Now take that and do 10 negative 1 of 1.33.
Oh, it's 53.
Okay, cool. So you're good. All right. So now we got that one, right? So technically, when you put it all together, right? You should get, this is the resultant, and it's 5 meters at 53 degrees. That's how you put it together as a vector component. Now, 5 meters at 53 degrees, what direction is that?
Northwest, northeast.
Northeast, right? So we could also say 5 meters northeast. The 53 is more specific, but a general is 55 meters northeast. So that's how we could also describe it, right? Now, here's the part where I don't want you to do any math anymore. Now let's think logically. So everyone come off of mute, or you don't have to, everyone have to come off mute. But now, if the math was giving you trouble, let's just think logically now, right? Okay. For the next one, I'm going to get rid of this. Hold on. Let's think. The next one, this one in the middle. What are the two sides that we see? Two components.
The opposite and the adjacent.
Yes, and how much are they? What are their values?
3 and 4.
3 and 4, right? So if we put them together, let me follow it here. Boom, right? The resultant is this one, right?
Mhm.
Okay. Now, we just did this problem, right? When I pulled it out and I made the triangle, right? 3 was here, 4 was here, or other vice versa, right? When we just did this, what answer did we get with the resultant?
5.
Are these not the same amounts for the sides?
Yeah,
So this resultant should also be what?
5.
5, right? Now let's think, right? When we did it, right? It was actually this one over here. So it was here, here, here. So we had 3 right here and 4 right here. We had 5 and we wanted to find this angle. Now, where is that angle at on this one? That same angle. Is it here, here, or here? 1, 2, 3.
3.
1, 2, 3.
What's in 3?
You're saying here. This angle is the same angle here.
Well, 2.
Let's think about it. First, let me make this easier. Let's say 1 is the right angle. So I'm going to start with 1 the right angle. 1, 2, or 3.
2.
2, right? So now we got this angle. So now this angle matches up with this angle, right? So now with it being there, we found out that this one, when we made it here, it was 5 meters at 53 degrees. So technically, if we're looking at it, what should this angle be?
Could you say that again?
We found that this angle was 53 degrees, right?
Okay.
So now if we look over here, right, this is the same angle as this one, right?
Mm-hmm.
So how much should this angle be?
53.
53 degrees, right? So now if this is 53 degrees here, right? We want to find out the angle between here Now, so now we know this is here. This is 5 meters.
Oh, like 180 minus 90 minus 53.
You on the right track. Now let's think about it, right?
It'll be northeast,
North,
east, west.
west, right? Now we found out that this angle in between, right? So now I done made this whole big thing, right? This angle right here is 53. Inside, right there, is 53. How much is now this angle? If I look from the drawing is a little bad, but I'm gonna draw it in blue. This entire angle, right? You see the blue?
It's obtuse,
It's obtuse. So how much would it be?
180.
Is it 180 or
Why do we need that angle though?
because we start from where?
But I thought we were looking at the right triangle, which doesn't include that.
It doesn't, right? But think about it. We need to know what this vector is in result of all 4 quadrants, right? Because if I just say, I could literally just say 5 meters at 53 degrees, right? But where would you know? Because technically 5 meters at 53 degrees is really northeast. But is this vector going northeast? Look at it.
No,
Where is
No.
this vector going?
it's going northwest.
Northwest. So how would I be able to describe it as going northwest? I have to talk it in regards to the other 4 quadrants. So now I'm looking for this angle here. You just said, Courtney, that it's obtuse. Now I have to figure out what it is. Now, when we drew that triangle, we know that this angle in between is 53. So let's look at it all. It's 2 ways to do this, right? Bless you. This green part, how much is this angle just in general? Just regular. How many degrees is this?
90.
90, right? If I know that this part right here up top is 53, how much is the bottom part going to be?
Whatever makes it 90.
Which would be what?
90 minus 53 is whichever.
Which is how much?
7. So it'll be 30. 37.
37.
37, right? So now I have 37, right? So I know that this bottom part now is 37. Now I'm gonna make it all in one color. It is, let's just say this yellow, right? This yellow is a straight angle. How much is a straight angle?
0.
Or on the other side is
360.
no, on the other side right here,
180.
180. So now I know that this little part between this red is 37 and this is 180. If I wanted to find this whole angle, I could just subtract 180 minus 180 minus
37.
37. I get how much?
Hold on.
It would be 90 plus 53, right?
43.
Or 90 more. Yes. See if you get the same thing. Do 180 minus 37 and 90 plus 53.
143.
What's 180 minus 37?
43.
143. So now
143.
you got the same answer because you did it 2 ways, right? You did 180 minus the inside angle, which would be 37, or you just added 90 onto what we already know was 53. So now we got 5 meters at 143
Northwest.
northwest. Good. So now we know that this angle is this. We know it's 5 meters, but what direction is it? Northwest. How precise is it? Oh, 143 degrees. All right, one more time. I'm going here this way, then I go down. So my resultant is this way. I pull out my triangle. and I'm here. I have 3 and I have 4. By doing Pythagorean theorem, how much is my hypotenuse going to be?
5.
5 again, right? Remember we started off with our first one? We knew it was 3, 4, 5. 5 here, 3 here, 4, and we found this angle. This angle was 53. Where is this angle at here?
Northwest. I mean, no. It's southwest. The angle is southwest.
Okay. Where is that angle that we just found? This angle right here, where do I put that? Between the 5 and the 3 or the 4 and the 5?
53.
But where? Between the 5 and the 3 or the 4 and the 5?
Between the 4 and 5.
This angle right here.
5 and a 3.
So I put it between where? The 5 and the 3 or the 4 and the 5?
I don't know. I'm confused now.
It would be between the 5 and the 3.
5 and the 3.
Yeah, that's what I said. Okay, I was right.
All right. And you said how much, Courtney? This is earlier. This was how much?
53.
So then this angle is going to be what?
180 minus.
Oh, no.
53.
No. This is 53. So this angle is the same angle as this one. So it's going to also be
53.
53. So this is 53. Now, we know that that's 53. Let's make it in general towards which we're going. You just said it. Which direction is that?
Southwest.
One more time.
Southwest.
One more time.
Oh, southeast.
Southeast. All right. So now, with it being southeast, we expect it between what two numbers?
0 and a 180. No, 270. Sorry, 0 and 270. I mean,
Or-
270 and 360. Well,
Exactly. Yep. So now that was knowing that, right? We really need to find this angle to figure out how far it is in relations to this. That's how we describe it. So now let me pull out this triangle, right? I know that this angle right here is 53 because we just found it. We have the 5 and we have the 3 and the 4, right? Now, relative to our axis, that's the same angle here, right? That we see. One more time.
I'm pretty sure she just said like 20% of the body.
Yeah, because she fucking eats.
Bro.
I'm sorry.
Now we have this angle 53 right here, right? So now we know that this angle is 53, but also we just established that this is 0 and also
360.
360. So now if I was to subtract this mini angle from 360, I get what?
Huh? Do it. Say it again, please.
This is 53, right? If I subtract 53 from 360, I get what? Or 360 minus 53.
Hold on. $37.
360 minus 53.
17. 317.
317, right? Now 317 is this entire angle right here, 317. And now let's do it one more time. So you found 317, right? In our quadrant space, where does 317 lie at? In which quadrant? 1, 2, 3, or 4?
4.
4, which we established earlier, is northwest, southeast,
Southeast.
southeast, right? And you already said it's southeast. So we're over here at 315. Does that match up now?
Mm-hmm.
So now we got 5 meters at 315. Okay, that was a lot. Now let's look at it. It says we off a little bit. I might be off in how I'm doing it. Hold on, let me see. I always mess up with the angles, but it's relatively in the same thing. Let me just give me 2 seconds to figure out how I got it. Oh, I know why. Because I always do it like, that's mad annoying. Let me take 2 seconds to explain. All right, give me a second. So it's the same process, right?
So like, is the angle that when they ask for an angle, it's always the angle between the vector and the x-axis?
Don't try and generalize it. Let me you can see my screen, right?
Hmm.
Let me do the first one. 'Cause I mess it up all the time too. So we're looking for this one, right? Sorry, the second one, right? Imagine my thing is here, right? Now, how I did it when I made my triangle, right? I went up in here, right? But generally, how they did it when they're making their triangle is going across this way and then up to where you get to the same spot. Therefore, when you make that, you're going to pull it out to where now your triangle looks like this, right? So you have 4 right here, and then 3 right here, and 5. How does that change everything? Now, the angle that was here, that was 53, is over here. So therefore,
But the answer will still be the same, right?
no, it's going to be different. But the 5 is the same, the magnitude is the same, but the direction is going to be different. So if I pull up my triangle, right?
Because I did it that first way.
53 is here, right? This one is 90. So what's the third angle going to be in the triangle?
37.
37.
Yeah, I think the answers come out to be the same. Either way.
Hold on. What we did, the math was correct, right? But I think what you have to do is where I might have messed it up at, is the subtraction part. So just add whatever reference angle is coming from, add that to that one. So what I mean by that is we found a 37, which was correct, right? Take the 37 and add 90 to it. That's what they got. So where you did 37 plus 90 to where you get 127. And then over here, when we did the same thing, we got 53, and then he's going to just add the first one. You add 90 to 57 to 37, right? So that's the reference angle in between. I think I'm actually starting to see it right now. 5, 3. And then the other one, you have a reference angle being 53. So you do 360 minus what you call it? Why did I just do that? 360 minus 53. Yes, that should be 30. That don't even make sense.
Why are you subtracting from 360? When you subtract from 180?
I'm looking at the last one.
Oh.
Yeah, I'm not even gonna fight with this. I always get to a problem with these ones. But really, as you can see right now, the reference angle each time is 53 that we're looking at. But that's not what I wanted you to see. I wanted you to focus more so on, do you see that? What do we see specifically about this triangle? What type of triangle is this?
All right.
A right triangle, right? What are the sides of this triangle?
3, 4,
Four.
5.
Yeah,
3, 4, 5. When we did this triangle each time, right? Were we able to find that the resultant was 5 when we did the math?
Yeah.
Right. So this is going to be for consistent. So anytime you see the sides where it's 3 and a 4, what would the resultant be?
5.
5. Now let's say if I didn't know one of the sides, right? But I knew the hypotenuse was 5 and one of the sides was 3. What would be the third side?
4.
4. Now let's say the other side I know was 4, but my resultant was 5, but I didn't know the last side. What would be the last side?
3.
3. So a 3, 4, 5 triangle with 5 being the highest is always going to be the same. Now, why am I doing that? Look at this one, right? We're going to do this one time, but I hope you see the same trend, right? Hold on. Let's draw this all together, right? I say I go 5, right? Then I go up 5, 7. I go across 7. Then I go up 5. And then I go 5. Technically, my displacement is this green line. Okay. I went here, here, here. My displacement will be this red line. Here, right? Now, for my X, I went how far? 7 and how much?
5.
5.
5.
So
So if I add them together, it's total
10.
7 plus 5.
12.
12. So now if I do, how much did I go up?
5.
5, right? Once again, my displacement is here. So if I go from here to here, now I have my triangle. Let's use Pythagorean theorem. A squared, I want to find my C. C squared, right? Oh, B squared. Sorry. So now I have 12 squared plus 5 squared. Twelve squared is how much?
144.
144.
And 5 squared is how much?
25.
144 plus 25 is how much?
169.
169. Now, because I got c squared, I want to find c. So I do 169 equals c squared. So to find c, I have to take the what?
Square root
What's the square root of 169?
13.
13. 13. This is another triangle, right? The 5, 12, 13. So anytime you see 5 and 12 organized together as sides, then you know the hypotenuse is 13. Now let's use this. Let me clear this. I'm going to draw it the same way as we had it here, right? Because we're going this way. What quadrant is this?
That's northeast.
Northeast, right? So now I could just treat it regular. It'd be between what two numbers? 0 and
90.
90. So let me do it. 5, 12. Sorry, 13. 12. I need to find this angle, reference angle, and then go from here. So now I can use, let's use tangent again. So I'm going to do tangent. I don't know my angle, but I do know my ratio of opposite over hypotenuse, which is 5 over 12. So now I'm going to do tan inverse. I'm going to be lazy. Tan inverse of 5 over 12. And that'll give you my angle. So do 5 over 12 and then take the tan inverse of that on your phones. Something like that.
Yeah.
23. Okay. So now let me erase all of this. Now we have our triangle, right? And we know that this angle is 23. And we know this result is 13. So when we do our vector, we say it's 13 meters at 23 degrees. Or what direction?
Northeast.
Northeast, correct. So let's do the same thing with this next one, right? We're here, right? Let's add up all the x's together. We got 7 here. And how much across? 7 and
5.
5. So together that's
12.
12. Now here I go down 12, but look how it changes. I go down 12 and then I go up how much?
12.
I go
No,
down
5.
12 and then I go up how much? Down 12 and up how much?
12.
Look to the right. I down 12, then I went up how much?
7.
7, right? So now, because I went down 12 and then I went the opposite way of 7, how do I add these two together, these vectors?
Negative 12 plus 7.
Negative 12 plus 7, which is negative what?
Negative 5.
Negative 5. Now let's think about that. What does that mean if it's negative 5 in the north and south?
It's going south 5.
going south. Here's my resultant vector. What direction is that? South.
East.
Southeast. All right, so let's add this together and make our triangle, right? We already established that this is east, and we're going 12, and then, actually, let me redo it. So we got 12, and we have 5 here, right? Now, when we just did this, right? We know that the resultant should be how much?
13.
13, right? So we know the result is going to end up being 13. Now, when we did it last time, we had 13, we had 12 on the bottom, and then we have 5. We know that this is a right angle. We found out this angle is 23. So now, relative to this type of triangle, right? The 23 is between what two numbers? Bless you.
17 and 12.
Sorry, this is a 13. 13 and 12.
13 and 12.
So 23 should be here. So if this is 23, this is, oh, I'm sorry, this is the right angle. How much is this other angle? And relative to this triangle?
67.
Yeah, wait, say it again.
67.
67, yes. Okay, cool. So we got that, right? Now, let's put this in all relative to here. So now we established that this angle should be 23. All I'm going to say is I would just do 360 minus 23. Now let me just see if that's the right answer. Yes. Okay. Okay. I don't know what's going. I always mess up that first problem, right? So now, what it's finding that if I come back, what we did here is now we established that this resultant vector is 13 meters at 337 degrees, or 13 meters southeast. But what was the triangle we pulled out? We have 2 of them, right? We just established the 5, 4, 3, and then now this one we just did was the 5, 12, 13. Now you might not remember the angle numbers, right? But you always remember these numbers, right? If you see a 3 and a 2 as the sides, you know the resultant is 5. If you see a 12 and a 5, you know the resultant is 13. You want to really remember this so you're not doing as much math. And then once you get there, you can figure out, do 10 to find the angle. But if you remember the angles too, then that'd be good. So let me keep going to get you to the last little part that I'm trying to do. One moment. Hold on, let me see something real quick. All right, let's put it all together, right? Oh, this is the last part. Then we can try and put it all together. Now we have our special triangles, right? So now we know we have our 13, 5 triangle, our 13, 12, and 5, and a 3, 4, 5, right? But now that's what helping us do a Pythagorean theorem. Let's look and see if we see the relationships between the different angles of a triangle, right? Remember I said earlier, let's remember the 30, 60, and the 90, and the 45, 45. I'm only just doing those real quick because I'm just going to tell you about it so we can get through it. But let's look at the relationship between them. So on this first one, right, I'm going to pull it out over here. I have my original vector, right? It's going to have 2 components. This is me making my triangle, right? I know I have a 12 right here. And then this is 30 degrees. So when I make it, right, I know that this is a right angle. So what does this other triangle, other angle has to be? If I know that this is 90, this one is 30, what is this other angle?
$60? No.
Yes. 60, 30, 90. It adds up to 180. So now me knowing that, right? I'm going to do this, right? So we're now, I want to find the individual components of this one, right? So now if I redraw it, right? Looking at the 30 and it's 12. From this 30, where is the opposite and where is the adjacent?
Opposite is the vertical and adjacent's the horizontal.
Okay, good. So now if I want to find the opposite, which function do I use? Sine or cosine?
Cosine.
For the opposite or adjacent?
Oh, sorry. Opposite would be sine.
All right, so let me just write that one first. So it's opposite, sine of the angle times is equal to opposite over adjacent. So I know the sine is here, right? What's the angle?
30.
30. We want to find the opposite. But do we know what the hypotenuse is?
12.
12, right? Now, real quick, right? Type in sine of 30 in your calculator.
Point 5.
0.5, right? So 0.5 equals opposite over 12. So therefore, the opposite should be how much?
6.
6, right? So we know this is going to end up being 6. Okay, cool. Now, to find the adjacent, we have to use which one?
Cosine.
Cosine, good. So now it's doing cosine, right? Let's do cosine. 30 equals adjacent over hypotenuse. What's the hypotenuse?
12.
12. Now, real quick, put in cosine of 30 in your calculator.
.866.
Just remember that, right? Now multiply that by 12 and you get what?
Uh, 10.4.
Okay, 10.4. Good. So now we just found the horizontal and vertical components, right? Now, that's the same process you do for this one at the very end, right? Let's go through this fast because I got 8 minutes. But let's look at this last one, right? If I know that the angle here is 240, right? What's this little bitty angle in between this 240 and also remember? These two angles right here, you got 0, 90, 180, and 270, right? So if I know this big angle is all the way over here is 240, how much is this little angle?
Uh, 240 minus 90. Oh wait, 360 minus
I know that that angle all the way around is 240, right? We could do this one, or we could do this one. What's the difference between these two? Yeah, let's do this one. I like this one. All right. I know this is 240, right? How much is this angle? This is 270. So I need to find out this little bitty part right here. If this is 240 and this is 270 on the side, what's this in between part? I know this angle right here all the way around is 270, but then I'm doing this little bitty angle right here is 240. I need to find this part, which is 270 minus 240, which is how much?
30.
30, right? So let me pull out that and make it in my triangle. And do the same direction. Here, here. This is 30, 60, 90. So now I have my triangle and I know this is 12. All right, cool. Because it's 12, we just did it, right? 30, how much was on this side on the opposite? We just did it. Because we did the opposite. So we did sine of 30. What is the sine of 30?
I think it was half.
A half, right? So that was 0.5. So therefore, the opposite should be 12 times a half, which is how much?
6.
6, right? And then the cosine of 30 was like 0.86, right?
Mm-hmm.
And that times 12 is like, it was like 10.4, right?
Mm-hmm.
Now I want you to remember that. We just did it. Don't worry about the numbers and the answers. Remember this part. We have this here, right? And we have, it was whatever this number was, like let's say this is, based off of this was X, right? This one was twice as this, and this one was 0.86 times 2 times this, right? Because it was the hypotenuse. So just remember this, right? I'll come back to this in like 2 seconds. All right, let me try and do this last one, right? So we see this last one is 45, right? I'm going to pull this out, right? This is 45. Now I'm going to have to use this to do intuition, right? But we're going to do it at the same way, right? What's the max degrees in a triangle?
180.
Say it one more time.
180.
If I know that one side is equal to 40, the other side is equal to 90, what's this last angle?
$40 or $45?
45, good. Now think about it, right? When we remember from geometry, when two sides have the same angles, what do we know about those sides? Take a wild guess. Please take a wild guess.
They're
Yes,
equal.
ma'am.
Exactly. Now let's see if that matches up with the math, right? If I want to find,
Oh, so we only have to find the answer for one side, and
see,
it'll be the
right?
same.
So now I got
That
14,
makes
right?
sense.
Let me find my opposite. What would I do? Sine or cosine?
Sine.
Sine of 45. And that equals opposite, which we don't know, over 14. You just said sine of 45 is how much? Sorry. No, ignore what I just said. Put in sine of 45 in your calculator.
0.7.
You get about 0.7. And then 0.7 times 14, you get what?
9.9.
9.9. Okay, cool. Now do the same thing. Do cosine of 45 in your calculator. This will be the last thing. How much do you get?
0.7.
0.7. Good. So now if I do 0.7 times 14, I should get what number?
9.9.
9.9. Are these sides the same?
Yep.
All right. Real quick. See how we got that? About 10 here, and then we got 10, 6, same thing here, and it matched up, right? But what's the most important part? This right here. Can we all see this? Hold on. Can we all see this? This is where we're going to start off on Wednesday, right? Really talking about the common right triangles, and this will get us to help us when we start doing some physics problems, right? This we want to use as least math as possible. We have 4 special right triangles, right? The ones that really help us out with understanding angles that we want to use trigonometric functions for are the 45, 45, 90, the 30, 60, 90. So what does that mean? Basically, if you have these two sides that you know equal the same amount, right? You can start off and saying, I know these two sides are going to be the same. So really to find the hypotenuse, I would just multiply whatever one of these sides is by √2, right? And that gives the same thing. Or you could take, if you know the hypotenuse, you can divide the other two sides by √2 over 2. On your calculator real quick, watch me. What is √2 divided by 2?
.7.
0.7. That's where we get the 0.7 from. Now, we can look at that same type of trend over here for the 30, 60, 90, right? This is the last thing. Now, so let's say we have 2x for the hypotenuse, right? We said one side is going to be half of that, which would be x. And the other side is going to be x times √3, right? Now, Lakshmi, one more time. Cosine of 30 is equal to how much? Sorry, sine of 30 is equal to how much?
It's half.
Half, which makes sense. So the half goes across from the 30, which is a smaller angle. Now, tell me if the cosine of 30 is equal to 0.86.
It is.
Now, √3 is equal to how much? Do √3 over 2.
0.86.
0.86. So that's where we get it from, right? But if you remember these triangles, you will be able to do less math. It's possible, right? But this is going to come in tandem when we see the next problem that we'll do on Wednesday. And then the last thing is looking at the Pythagorean theorem with 3, 4, 5, and a 5, 12, 13. Really just knowing that if you remember two of the sides, right? Now, if you have a 3, 4, 5, if you see two of the sides are equal to 3 and 4 as two of the smaller sides, you know the hypotenuse is going to be equal to 5. Or let's say you have the hypotenuse that you know is 5 and one of the sides, and you can figure out the other one. Same thing for the 13, 5, 12. If I know my hypotenuse is 13 And I have a 12 on one of my sides, and I know the last side is 5. This was a lot of math today, but I'll bring it all together next class where you see within the physics. So that was the last thing. So we'll stop here for tonight. Thank you for bearing with me. And
Can
Wednesday.
you go back to that slide real quick?
Okay, go ahead. Yes.
Okay, thank you.
All right. So that'll be it for tonight. I'll post the other recordings. Oh, wait. Do not leave yet. Hold on. Yeah, some people that already left. Give me 2 seconds. A good number of y'all were interested in the quantum computing. Everyone fill out this form. Fill out this form, put your information in it, put that you go to UDC, and ignore the very last question, but interest that you want to learn about this. I want everybody to fill this out. It should look like this. This form right here. This is so we can use the Q Control software throughout our class. Put your first name, last name, your email address that you go to UDC, whatever major you are, put undergraduate. And then when you say like this, just put in here one for yourself. I need a license for myself. And then just ignore this one or put NA. Submit this and then just send a screenshot to me on Blackboard that you completed it. And just do that before Wednesday. Okay? All right, sounds good.
Hey, will you send that link out in like an email or announcement?
Yeah, I'll send it on Blackboard.
Okay.
Yeah. So just fill that out and we'll go from there. I will see you guys all on Wednesday. I'll stick around if anybody had any questions.
I have one question about the lab.
Hold on, let me stop recording.